Welcome. We're very excited to share a data management approach we took at Yahoo due to the challenges we were facing. And really the primary premise behind talking about data discovery here is that we didn't want to introduce an additional component in the stack. We already have a lot of stuff. So that's the whole premise. So the idea is that you wanted to discover all the data that's on Hadoop clusters at Yahoo and do meaningful things with it for the rest of the company. So open it up in ways that you still have control over. So that's the idea, and how we did it is the approach we're going to share here. So before we get started, let me introduce myself. I'm Sumeet Singh. I'm a Senior Director of Product Management responsible for Hadoop platforms and products at Yahoo. My co-speaker is Thiruval Thirumulan. He's a developer in the Hive team and works across Hive, Hive Server 2, and HCatalog. With that, let's get into the talk. So just so you understand how we've structured it, we'll start with the data management challenge that we had at Yahoo, and different companies have different challenges. Maybe you can draw a lot of insight from what we were facing and what you might face and seek similar solution for it. Then we'll talk about Apache HCatalog in depth, because we based a lot of our solution, the approach that we've taken off of HCatalog. Then we'll talk about how to get your data into HCatalog. So we call it data registration. You may call it something else. And then we'll talk about the specifics of discovery, the tool itself, and how we sort of discovered all the data on our Hadoop clusters. And then we'll discuss some thoughts around what we did in terms of opening up that data to the rest of the company. So a lot of issues around governance, audit, and other things would come in here. And then we'll open it up for Q&A in the end. Okay, so let's get started. What's the context of Hadoop at Yahoo? So we've been doing Hadoop for about 10 years in production. And what happens is that, and this is true for any web scale company, all our products and properties generate a lot of data. So we're talking about 100, 150 billion events a day. And you want to process that economically, right? So what we do is we bring all that data, all that click stream, all the different types of events into Hadoop, into a common source of information for the company. We also pull a variety of data from other sources, be it web crawl or third-party content, and they all land up in the common place. The idea being that you should be able to share that data, enrich that, dedupe it, and extract the maximum value out of that for the entire company on a shared multi-tenant platform, right, which is Hadoop for us. And then we process that data, extract as much insight as we want to extract out of that data based on whatever business necessity is, apply that back to our products and properties in terms of personalized user experiences or online advertising and other things, right? And of course, once the data is processed, you can do BI analytics and reporting on top of that. So a good example would be budgeting for an ad campaign or other things, right? So internal reporting, external reporting, all kinds of different things. So that's what we're talking about here. That's the setup. So when you do this, when you bring all your company's data together in one place, particularly at web scale, one of the challenges you would start to face is the magnitude of data that's flowing into the system. So for us now, it's reaching 600 petabytes across Hadoop and HBase, which is difficult to manage. And then the infrastructure keeps growing. If you just look at the growth in storage over the last 10 years, particularly in the last 5 years when I've been tracking it, roughly 70 to 80 petabytes get added to the platform every year, right? So it's about a 22% CAGR. And that's what we wanted to manage, roughly 1.5 billion files and directories. How do you make sense out of that? How do you control that? How do you open that up for the company? How do you manage it? How do you govern it? That's the premise for why we wanted to do data discovery, right? Without introducing an additional component in the tech stack. So this is how we then process all that data. MapReduce and Pig have been the traditional sort of tool to process all that data. And in case of MapReduce and Pig, the schema for the data, the file format, the storage format, and other types of things are encoded in the app itself. So they're aware of the location, they're aware of the schema of the data. And then came along Hive, which introduced yet another component in the ecosystem, which was the metastore. So then you were referring to the metadata for actually processing that data. or referencing that data, right? So we got Pig, MapReduce, the traditional sort of tools that we have at Yahoo, and then Hive, which was 3-4 years ago. So we did introduce a meta store, and we started to invest in scaling it. And of course, there is Oozie on top, which is how we schedule most of our jobs on the platform. Right, so that's the scheduler for Hadoop. HBase is largely the same story, where you work with table input format, output format, storage handlers, but the story of how you process data in HBase is largely the same as Hadoop. Okay. And of course, you have Oozie, just much the same way. Just to give you a sense of the variety of tools that we have, still Pig sort of dominates from a volume perspective. You will see a lot of Oozie launcher jobs that tells you that about 70% of all the compute happening on the platform is coming from Oozie. And then there is a bunch of Java MapReduce still, and Hive, and a bunch of other things. The data management sort of tools that also launch mapper jobs. Okay, so there's a mix of tools that are operating on the platform, mix of tools for producing data, mix of tools for consuming data on the platform. So in essence, what happens is a variety of people would capture those events that I talked about, the 150 billion events, would ETL that on the platform itself and produce feeds that are then consumed by the rest of the company, again, off of the same platform, right? So the platform is both a source for data as well as downstream consumption for data. What happens if you are set up like this, if you've brought all your company's data in one place, is that your data essentially can be shared across a variety of tools. So let's say Pig might be producing the data, but you may be consuming it off of Hive, right? Schema and semantics knowledge may not be brought across the company, so the person who produces the data knows really well about every individual field in the data feed, but others may not, right? And neither would the semantics be clear, even if the schema is clear. Schema evolution, and when the schema changes, the downstream communication of that is not always effective. The other issue is that you have a lot of sort of concerns around opening up that data. Some of that could be sensitive, some of that could be public, but they're all in the same place, being shared by 1,000, 2,000 developers, right? So you want to control it in a nice fashion. Ownership of that data is often not clear when it lands up in a common platform. Lineage, integrity, data quality, all those become an issue. And then audit and compliance is important these days. You have to satisfy those requirements, as well as, the 600 petabyte. How much of that is meaningful? I don't know. It's hard to figure out what's meaningful, what's not, what's retained, what's a wasteful retention, and what's not, right? So you want to eliminate any wasteful retention and only retain data for as long as possible. It's needed for. Okay, so we believe that Apache HCatalog, along with the data discovery tool we have developed, solves a lot of these problems that I've just talked about. And most companies would face these challenges. So this is the tech stack we have assembled. We have built some of them over the years. We have brought several from outside over the years. And as you can see, HCatalog, which is the Hive metastore opened up for Pig and MapReduce, was already there, and we were investing in scaling that, right, the backend. So the idea was to why not use that as a sort of solution to this problem, which is what we embarked upon about a year or two ago. And it has given us good results. So we'll just talk about what the approach was. So this is what HCatalog is. Essentially, since Hive was introduced, Hive's metastore is opened up, and you have wrappers around Hive metastore, which is HCatalog essentially. And what it allows you to do is it allows the other tools in the ecosystem, like Pig, like MapReduce, as well as Hive itself, share data, right? So Pig and MapReduce can also start working with the DB table partition type abstractions that you're used to when you work with Hive. Right, so all of that now, all these tools now start to interoperate on the data in HDFS or in HBase. You have a single SERDE per record format that you deal with, and the storage handlers allow you to abstract out the storage format details and the locations of the files. So that's what HCatalog is, and Oozie worked just the same way. The security aspects of the platform with Hadoop Kerberos works the same way. You get authenticated against the meta store, as well as you have delegation tokens if you have long-running MapReduce jobs, okay? So nothing changes. You just open up the Hive meta store for other tools with client libraries around it, wrappers around it. If you work with Hive, again, you must be familiar with this data model. HCatalog follows the same data model. So you have a DB abstraction right at the top, which you can think of it as a namespace. Or an administrative boundary, and then the schemas are encoded, which are essentially data feeds, or in a sense, what people work with as tables, and partitions are the units that you would work with or consume. So like date, a data for a day, the next day, the third day, so it's partitioned by date, and that's the unit of data you work with. And you have other facilities to make things faster, which is like SKUs. If you have SKUs in your data, Hive can split it, or HCatalog can split it. Buckets are essentially clusters created. Again, these are for faster access, so we're not going to get into a lot into that, but we will touch upon the other things. Okay. So then there was, as I said, there were a lot of data on the platform already, and we wanted to register all that in HCatalog. So most people, if you have usable data in HDFS already, what you would do is create external tables in HCatalog and specify the location of where the data files are. So the data is not managed by HCatalog. It's still managed by the user. So for example, if you drop a table, your data will still be there. And most people were comfortable with that, people who were not working with HCatalog. So we started registering data in this way. And of course, you can add partitions to that table. But you would not do that manually, particularly when you're talking about the scale I'm talking about. So we'll talk about how to deal with partitions or additions of partitions on a daily, hourly, or whatever the frequency may be basis. Okay. All the DDL, DML that you're comfortable with with SQL or Hive works much the same way with HCatalog. So you have a variety of ways to get your data into HCatalog. You can load your data from HDFS or local file paths. You can insert query results into the table, or you can add partitions manually. And then now Pig and MapReduce starts to work with the same abstractions of DB, which is the namespace for a project table, which are feeds, essentially, or mimics feeds that you produce on the platform. With the abstractions like HCatalog or HCatStorer for Pig and HCat input format and output format for MapReduce, right? So now MapReduce and other things do not necessarily have to carry the schema, the file location, and file format in the code itself. So if things change underneath, you don't need to change your application, okay? That's the biggest benefit of using HCatalog with all of these tools. Then, as I said, adding partitions on a daily or hourly basis at the scale I talk about is not possible to do it yourself. So we have a data lifecycle management tool called Grid Data Management, or GDM. And essentially, the idea is quite simple. No matter what you use, what we do is that the feeds that the GDM sort of acquires, it's a lifecycle management tool, right? So there's an acquisition component, a replication component, a retention component, and an archival component. All data lifecycle management tools would do those four basic things. So during acquisition, the feeds that you acquire are actually mimicking tables. So tables are created in the metastore that mimics the feed that you acquire on Hadoop clusters. If you have existing data in HDFS, you could extract out schema from that. There are tools such as Growl available in HCatalog to do that. So the feeds are acquired, and HCat client libraries can be called to add partitions in an automated way, right? So if you have a tool that's managing data in and out of clusters, you could just add another client library or client call into it to work with HCatalog. And then HCatalog has a nice property to trigger notifications when partitions are added, right? So we'll talk about that in just a second. And if you replicate this, if you manage your infrastructure across multiple data centers or multiple clusters, you could replicate that if you need to, much the same way, and call the same client APIs. Okay. And partition drops once you delete the data works the same way. Okay, so HCatalog is another interesting property that you can trigger notifications when changes happen. So when you're adding data to it, like partitions, you can trigger partition availability notification, and these are JMS compliant, so you can use any message bus like ActiveMQ or other things to trigger these notifications and work across your ecosystem with these messages. Okay. Then, as I said, most of the production jobs is not something you would do by hand. So Oozie is the workflow scheduler for Hadoop, at least at Yahoo. As I said, 70% of our 30 million jobs, roughly a month, get scheduled through Oozie. So data producers actually write data in HDFS, and they would also update the metadata in HCatalog in terms of partition availability, right? Then what Oozie does is that it will directly poll HCatalog for partition availability when a workflow kicks off. And if it doesn't find that partition, it would register that topic in that message broker, saying, I'm interested in listening for events related to this table. As partition becomes available, you basically push a notification to the message bus saying, hey, data is available. Whoever's interested in consuming it, it's ready now. Right? And then your work, this partition, since Oozie was listening to it, it triggers its workflow or processing again on data availability if it's dependent on data availability. So it does multiple things. It reduces pressure on name node where Oozie would directly poll name node for data availability. And it also makes things a lot more real time, like when the data is available, your workflow kicks off instead of you continuously polling for whether the data is available or not. Okay, so with that, we've seen sort of, HCatalog, technically how it works, how it's integrated with other components in the platform. I'm going to hand it over to Thiruval to talk about the specifics of discovery now.
Thanks, Sumeet. So far, we saw how do we register data in Metastore and the ecosystem that we have at Yahoo. Now, we have like about 20 plus clusters, and we have Metastore deployed on all the clusters. Pretty much all the data, all financial, all critical production data is in Metastore. Now, if you look at all the Metastores holistically, you'll get a unified view of all the data that we have on our grids. Now, what can we do with this? We can build something like discovery on top of all of these metadata. So what do we mean by discovery? One, you should be able to pick up a cluster and then look at what data is there in it, browse it to the lowest level. Two, if you're looking for some data, and you should be able to find it just within a single click. So we have 20 clusters, and I said 3 data centers, and it'll be extremely hard for you to go to a gateway, launch Hive, do stuff like that. Instead of that, we built a web application which does what discovery is mentioned here, and it connects to all the metastores across all of these data centers. So what does it solve? If you can go to one web application, and then you can look at the schema of any table. So that is the source of truth. You don't have to go anywhere else. And it will help you identify the owner of the data. Hey, I don't know what's the frequency of this data, whether there is a problem, the data is not available, you know whom to talk to. If there is a quality issue, you know whom exactly to talk to. Some of our users use the same cluster for both staging and production environments. So when you want to consume, you know which table to actually pick up. So we tag the tables, that this is a staging table, this is a production data, or this is a financial data. We tag it in different ways. It's all, again, best practices. And whenever your user wants to look at a data, the first thing they want to do is how does the data actually look like? A select star limit. So that's a very common use case, and we have to optimize that because when you onboard, you look at that. A schema also changes over a period of time. So we want to record the change, and we want to let people know this used to be like this, and it has changed now. So if you're a downstream consumer, you need to change your data definitions and so forth. Lineage is another thing that we need at Yahoo. We have huge pipelines. Some of them run on one cluster, they generate the data, and then they copy that to another cluster, and then there are consumers of it. So if you have a question with the data, or you want to trace its source, or if you want to know where it is low, you need to understand the lineage. So the features that we do for data discovery are these two. So with respect to browsing, you should be able to look at all the tables, the schema, all the details about the table, and you want to know what partitions are there and what are the unique values of partition. And with respect to search, you should be able to search based on various criteria. We started like very simple, table name or column name, schemas, and all that. Now, some of what we see here is actually based on the use cases we arrived at. For example, there is a team which produces audience data, and you want to know what other data they produce. For example, from Flickr team, there is a what all data they produce. Some of the data can be produced in various tables in various other colors. So how do you get all that? And we sometimes we see people using different types of storage formats, and you want to track down who they are, and you want to help them migrate to ORC format or RCFL format or whatever you want. And if you're already a consumer who has spec scripts and you want to convert the use, you want to connect to Metastore and then start using the storage abstractions. It's easy for you to search based on your location and then just change your tables. You don't have to get on the mailing list, ask people, trace the owner, nothing. Again, the properties, you can also search based on properties. You want to know all the staging tables or all the production tables, all the finance tables. It's all easy. Now, this is a sample UI. It's already in production for a while. And so this has the first layer. You see the search tables. So for example, I can search for Flickr metadata, and then I can get all the tables grouped by the clusters where the table is available. And you also have an idea of whether you have ownership of this table or not. If you don't have ownership, you can gain ownership. Sumeet will talk about that in a little bit. And on the left side, this is the browsing use case where you choose a cluster, and you can look at all the databases along with their descriptions. So you don't have to, hop 3-4 times and then find the data you want. And on the right-hand side, we have the table results. So whether you browse or whether you search, your results will be there, and you can just click on the table and it will take you to the table view. This is where we see all the table level metadata, the owner, the description. We recommend people tag their tables, they add appropriate comments, an iList, or a wiki page which describes more about it. Whatever it is, we ask them to annotate the table. In a similar way, we ask them to annotate the partitions. And so on the bottom side, you see the list of partitions in the table. Now, if you click on each of them, you get the list of all unique values for that partition. Some of the tables we have are partition 2A, some of them are partition 5As or even 6As. We have seen those kinds of use cases. So if you have a country or a market or a domain or a device, these kinds of partitions, the first thing a user wants to do before they run a query is, what are all the unique values for these partitions? What are all the different values of devices? The device I want, is it supported there? Is it actually partitioned there? You can look at all of them just by looking at the metadata. Now, this is the deployment or physical view that we have. It's just illustrative, and we have deployed it on all our clusters. So we have 2 data centers in this, and then each and every cluster has a Metastore server. In reality, we have a bank of servers to handle the load. And then we have a web server which is actually co-located along with the Metastore server. We also use it for administrative purposes. We also use it and expose REST APIs for browsing, search use cases. And then the UI is modified to talk to all of these clusters and then get the results. Now, in production, we've seen most of these queries take less than like 1 to 2 seconds. You actually get the results by talking to all the 3 data centers that we have. We don't have HBase here. We started with HDFS, and then we can slowly add HBase to this mix. It's pretty easy. So based on the design is, we have a single one-stop shop site inside Yahoo for all the grid developers, and we integrated our tool along with that. And for both the search and the browsing use cases, we want to audit who's looking at what data and what operations they're performed, and we can use it for other compliance purposes. We don't have ACLs yet, and we are doing SQL authorization, and based on that, we'll actually add ACLs, we'll integrate that to the discovery. So one of the decisions we had before was to integrate the discovery tool along with the production Metastores. So you can either talk to the production Metastore, which in some cases adds load to your databases, or you can actually fork your database and then have a replicated database, which could be even 1 day old and have read-only HCatalog instances. Now, we started directly on production, and it's been pretty good so far. So there are two APIs that we added for Hive Metastore, and these weren't there before. The first one was with respect to search. We took care of all SQL injection flaws and all of that. So it basically searches across table name or table comments, column name comments, location, partition properties, ownership, all of these fields, and then it'll get you the results. It's a pretty simple ranking. If you search for Flickr metadata, and if there is a table Flickr metadata, that one ranks first, and the rest of them goes behind. So this has been working pretty well so far. And given our history with Metastore deployments for close to three plus years, we have seen a lot of load on the database. So any API that we write has to be extremely light on the database. For example, the search was the biggest challenge we had, and most search results, even on the biggest cluster, return in less than 100 milliseconds. So this is something that we have spoken to other people, and they're interested, and we'll be contributing back to the community. And the second thing that we wanted was the unique partition values, the one that I showed in the table view slide. That one is not there today, and a lot of consumers have been asking for that feature, and we added a new API, which is just a Metastore API. So whenever a user queries on the Hive command line or from the discovery tool, it's just pushes that query to the database, and then it gets the results and streams it back, which is again less than 10-15 milliseconds. So, and we also support filtering and ordering, so you can actually extend it to other kinds of queries that we use from Hive, and it's been tracked in that Jira. I don't know, maybe we have a small patch or a design. The other optimization, like I said, if you want to peek into the data, like see the top 10 rows or 20 rows, the current implementation is extremely resource hungry. We have seen this one is actually tied to Hive server, and even with 1624 GB of heap, it actually goes out of memory very quickly, because some of the tables have hundreds and thousands of partitions, and the moment you start looking at the data, and most people look at the audience data, which has around maybe 100,000 or 150,000 partitions or something, and the moment you do that, the server goes out of memory. The resources are too, it actually consumes a lot of resources. So we optimize to use very lightweight objects. We have done a lot of work in this area in the community, and this is another work that we have done. And this is close to real time. The moment you want to look at the data, within a few seconds you have it on the screen. Again, this is tracked in 9573. So the other things that I mentioned in discovery was both lineage and schema versioning. With lineage, you want to understand who your source of data is and how your data is produced. You also want to understand what are all the jobs in production that actually led to this query. Sometimes a job could have failed and someone was looking at it, and then you want the results quick. So it helps to understand ownership of all your source datasets and your derived datasets. It also helps you understand the bottleneck, where it is low. For example, a cluster which produces the data could be under maintenance window, and you can be prepared for it. Now with lineage, you can also understand the quality of the data. With Hive statistics, you have more than just row count, and you can actually write just metadata-based queries to understand the quality of your data. You don't have to launch a job and compute whether the data is quality or not. There is one large data set that we have. The size of the data set for just one partition is 750 terabytes, and if you want to do data quality on that kind of scale, launching a job doesn't really help. So, and what are the challenges that we have? So do we want to do data flow? Do we want to do control flow? Now, both of them are important, and both of them have their own use cases. In data flow, you say, these are my source table 1, and this is a target table. And how was this table generated from this table? Or maybe you could join 3 or 4 tables, and what queries were actually used to generate this table? Now, in a similar fashion, if you have more than one tables, which is what we usually have, you can get an overall view of 3 or 4 tables and all the Hive jobs or the pick jobs or the pick queries which are actually used to generate that table. Now, if you attach a job or Oozie or a coordinator information to it, then it becomes a control flow. And what do we want to do? Depending on that, we have to annotate and we have to map and generate the data accordingly. And do we want to do it offline or real time? We actually built a tool which was an offline tool to generate lineage across one of the largest data sets that we had. And it was that which led to us to think about the lineage. Now, if you want to do it real time, there are like so many places which you want to tag and which you wanted to start monitoring, and whether you want to have a graph DB or not, and how many with 20 clusters, how do you want to store that? Do you want to store it in one place? Do you want to have a unified view again? And all of those things become a challenge. Software stack is again a big thing. So if you have one distribution, it's much easier to manage the stack. If you are like us, where pretty much most of the Hadoop components were born at Yahoo, and everyone will be using a software at different stacks. We still have people writing MapReduce programs, and they use HCAT output format, input format, and we have people who write data in HBase and import to HDFS. We have all sorts of use cases. How do you ensure you manage lineage across all of them? And there is a new code in the blog, which is Apache Thais, which we are adopting, and that has multiple DAGs in the same application master. So how do you take care of lineage, including Thais? So all of that became a huge challenge for us. Now, this is a simple example which basically tells you where there is a table, a source partition at stage 1, and we have a dimension table at stage 2. The first step most people do when the data gets into HDFS is convert that to ARC or into a Hadoop friendly format, and then they expose it to other users who, for example, there can be a second consumer who aggregates it and puts it into a Harley table, and a third consumer who can actually aggregate that on a daily basis and maybe import to Oracle or maybe export it outside and then use it for other purposes. So if you have statistics along the way, you can use that and the lineage information to programmatically track statistics without really launching jobs and computing multiple tables. So schema versioning is another thing. We have had the same data sets or the largest data sets for a long period of time, and users who are extremely familiar with it want to know how it changed over a period of time. This is again an illustration of what we are planning to do. There are two ways with which you can do that. As an end user, you can use the notifications that actually are generated, the one that Sumeet talked about. You can take that. You can actually consume the alter table notifications, and you can write your own schema versioning on your side as an end user. From a platform perspective, if you want to provide schema versioning, we are watching the HBase work that is happening in the community. There is a work to store the metadata not in a database but on a HBase. With HBase, you get all this time series thing for free, and we are also watching that to see whether, as a platform, we can provide a schema versioning. So with that, I'll give it to Sumeet.
So as you can see, without introducing really any other stack component, we've gotten 600 petabytes quite under control. Not all the way, but fairly deep now. And Hive, but HCatalog is not a single solution. It's a set of solutions that's with Hive Server 2. HCatalog, all of that is open source, and there's something called a Starling, which is a warehouse we have built and not open source yet. Let me talk about that and how that solves sort of the audit and compliance issues. This is the physical deployment of this sort of ecosystem of things. There are Hive Server 2 installs. Essentially, they scale horizontally under a load balancer. And then they have support for concurrent client connections, so you can bring in all kinds of clients you want, like BI tools like Tableau, MicroStrategy. You can directly thrift RPC to the Hive Server 2 for queries. You can bring whatever you want. Like, we don't care. We call it limitless clients, essentially. That's the idea. You can bring in any type of reporting or BI client as you want, a visualization client. On the Hive side, you have, of course, Hive CLI, through which you fire queries, and a lot of people do that today. A lot of people do that programmatically through Hive Action with Oozie. And so what you're working with now is most of the data registered in HCatalog, the metadata registered in HCatalog, and working with a schema type abstraction on top of that data, irrespective of what tool gets used. On the Hadoop platform, right? So Hive now supports both batch and interactive SQL, so you work on that data in either mode with MapReduce or Thais. And then, as I said, you can bring all that data to your desktop in numerous ways. Call that data to desktop or D2D. So you can start opening up that data now for accessing through other tools, right? But there's data governance, right? So we have a governance team in Yahoo too. I'm like, whoa, wait. You can't just open up all that data. We have lots of sensitive data. There are revenue information. There are other kinds of things. I need governance around it. So okay, that's easy. Since we had the discovery portal built with an abstraction of metadata for all that 600 petabytes, we asked governance team to, okay, go ahead and classify this data. Tell me which one's sensitive, which one's not. Now you have a catalog of all the data on Hadoop in HCatalog. So we started classifying that, and we've done like the first two. If it's a public data, it's no-brainer. Manager approves, employee gets access to that data, done, right? It's not sensitive, not a big deal. It's all automated. Then there are types of data that are kind of semi-sensitive. And what we want to do actually is to have the employee acknowledge that he has taken the governance training. He understands the security risks of working with that data. So we have integrated the tool with learning management system portals, and most of these learning management systems are cloud-based. They'll give you an API to check for certificate completion for an employee. You could do that, so that satisfies governance requirement number 2 for non-sensitive data. Then there are financial data, and the moment you request access to that, great, you can have access, but guess what? You're going to become an insider, and you will have blackouts put on your employee stock purchase plan and other things. So your whole sort of stock account goes into a blackout period every time we do quarterly results, right? So that integration can happen if you've classified it as financial data. And if it's restricted, say, let's say, email or other things where we have made promises to our consumer never to look at it except through machines, then it's up to the owner of that data, and it's his discretion whether he allows that workflow to continue granting access to the requesting employee or not, right? So governance can be, again, controlled, or access can be controlled through that single portal. As I said, fine-grained access is also possible with SQL-based authorization, not just storage-based authorization. So Metastore also has its authorization, which you can control with SQL-style authorization, Hive 13 and beyond. And then we gather all the logs from different clusters and different sources into a common place. And the idea behind gathering all that, and it's an Oozie workflow, which actually CPs all the logs from various systems into a common warehouse, okay? Which is, again, built on top of HCatalog. So the raw files are in HDFS. The metadata for that is in HCatalog, right? So essentially, you've gathered all the logs, cleansed them, put them in tables where you can make sense out of that. And then, again, all those clients that I talked about can actually query that, right? So if you want to look at who looked at what type of data at what time, it's very granular. Like, you can go to the nth level of detail in terms of auditing the platform. And we call that sort of that warehouse styling, which is a kind of a separate system in its own. But what it does is that it allows you to audit and satisfy any form of compliance requirement that may be imposed by different sort of agencies that would come around. And then it also tells you what's being used, what's not being used. So you can eliminate things that are wasteful, trigger sort of alerts around wasteful retention for data. So again, in summary, all the challenges that I talked about in the beginning, as you could see, can be solved in a very simple fashion with just native Hadoop components, which are almost all open source. And then at this point, if you have questions, we're happy to take that. We also have office hours at 4. So if you're interested to talk more about Hadoop at Yahoo, we could do that. GDM's non-open source, but something called Falcon, which is very close to GDM, is open source. Yeah. What else?
Other questions? Okay.
So I am not familiar with Navigator, but I think Navigator also does governance and audit. We do not have the luxury at that scale to sort of buy vendor stuff. So we kind of just went native. And I think we've got almost all these problems solved. I don't see any issue in just using HCatalog. And particularly at that scale, none of those challenges are going to go away irrespective of what tool do you use. So we'll go about optimizing Metastore, optimizing Hive, optimizing wherever we see optimization opportunities to make this work.
Okay, maybe one last quick question. No? Okay, let's thank the speakers.
Thank you.